Good day, today we will speak about strong hypothesis. If I do this, then will happen. Sound familiar? It should. This formulaic approach to making a statement about what you think will happen is the basis of most science fair projects and much scientific exploration. Following the scientific method, we come up with a question that we want to answer. We do some initial research, and then before we set out to answer the question by performing an experiment and observing what happens, we first clearly identify what we think will happen. We make an educated guess. We write a hypothesis. We set out to prove or disapprove the hypothesis. What you think will happen, of course, should be based on your preliminary research and your understanding of the science and scientific principles involved in your proposed experiment or study. In other words, you don't simply guess. You're not taking a shot in the dark. You're not pulling your statement out of thin air. Instead, you make an educated guess based on what you already know and what you have already learned from your research. If you keep in mind the format of a well-constructed hypothesis, you should find that writing your hypothesis is not difficult to do. You'll also find that in order to write a solid hypothesis, you need to understand what your variables are for your project. It's all connected. If I never water my plant, it will dry out and die. That seems like an obvious statement, right? The above hypothesis is too simplistic for most middle to upper grade science projects, however. As you work on deciding what questions you will explore, you should be looking for something for which the answer is not already obvious or already known to you. When you write your hypothesis, it should be based on your educated guess, not on known data. Similarly, the hypothesis should be written before you begin your experimental procedures, not after the fact. A step in the process. Keep in mind that writing the hypothesis is an early step in the process of doing a science project. The steps below from the basic outline of the scientific method. Ask a question, do background research, construct a hypothesis, test your hypothesis by doing an experiment, analyze your data and draw a conclusion, communicate your results. Hypothesis tips. Staff scientists offer the following tips for thinking about and writing good hypotheses. The questions come first. Before you make a hypothesis, you have to clearly identify the question you are interested in studying. A hypothesis is a statement, not a question. Your hypothesis is not the scientific question in your project. The hypothesis is an educated, testable prediction about what will happen. Make it clear. A good hypothesis is written in clear and simple language. Reading your hypothesis should tell a teacher or judge exactly what you thought was going to happen when you started your project. Keep the variables in mind. A good hypothesis defines the variables in easy to measure terms, like who the participants are, what changes during the testing, and what the effect of the changes will be. Make sure your hypothesis is testable. To prove or disprove your hypothesis, you need to be able to do an experiment and take measurements or make observations to see how two things are related. You should also be able to repeat your experiment over and over again, if necessary. To create a testable hypothesis, make sure you have done all of these things. Thought about what experiments you will need to carry out to do the test. Identified the variables in the project. Included the independent and dependent variables in the hypothesis statement. Do your research, you may find many studies similar 2 years have already been conducted. What you learn from available research and data can help you shape your project and hypothesis. Don't bite off more than you can chew. Answering some scientific questions can involve more than one experiment, each with its own hypothesis. Make sure your hypothesis is a specific statement relating to a single experiment. Putting it in action. To help demonstrate the above principles and techniques for developing and writing solid, specific, and testable hypotheses, there are offered the following good and bad examples. Good hypothesis. When there is less oxygen in the water, rainbow trout suffer more lice. Aphid-infected plants that are exposed to ladybugs will have fewer aphids after a week than aphid-infected plants which are left untreated. Poor hypothesis. Our universe is surrounded by another large universe with which we can have absolutely no contact. Ladybugs are good natural pesticide for treating aphid-infected plants. Like all scientific ideas and explanations, hypotheses are all partial and temporary, lasting just until a better one comes along. That's good news for scientists of all ages. There are always questions to answer and educated guesses to make.